y equals 2x ln x. So let's draw the line 2x then. Here it is here. So we want the product of this straight line. We don't need to do the negative side because the log's not defined. And let's draw a logarithm. So it comes up at 1, doesn't it, through 0 there, and then turns on itself and goes along here. So that's what we've got. This value is 1, log of 1 is 0, and 0 times the value is going to still be 0. So that can be one of our coordinates here at the value 1. So what have we got then? Well, we got, when we get x is small, this goes to minus infinity, this just goes to small. So if we tried, say, 0.01, that would be 2 over 100 of log of 0.01. That would still go to 0. It would tend to 0, wouldn't it? So if you try that on a calculator then. So we need to type in 2x, 2 times x. We'll try 0.01 just to see what value that is. ln of, what do we want to do? 0.01, isn't it? 0.01, close bracket, equals minus 0.09. So very, very small negative when x is 0.1. If we went back and we put 0.01, let's put that in, just to have a little look at it. And let's go back here, sorry. Okay, I'll get the hang of it in a minute. And then we get minus 0.01. So we're still very, very small. So when x gets smaller and smaller and smaller, it looks like it tends to 0 from below. So that's what we've got there then. That's what we thought would happen. So this tends to 0 a lot faster than this tends to negatives. So it's going to come from there and be negative. It's going to go through 1. And then after 1, it's going to be positive. So it's negative here, like so. And then after that, when we get 100, say, the 2x times that, it's just going to get large, isn't it? This is going to be bigger than 1, so it's going to go up higher than 2x. It's just going to go up. So it looks like it's going to go, just carry on going up, like so. Yeah? Let's have a look at that. A gentle sweep of a curve going increasingly higher. Let's get y dashed then. Here, y dashed. It's a product, so it's u times dv dx, log goes to 1 over x, plus v times du dx, which is 2. So that equals 0 when 2 plus 2 ln x equals 0. So ln x must equal minus 1, mustn't it? Because the minus 2 comes over, divide by 2, you get minus 1. Undo the log, this is log base e, so the e comes underneath and hits the minus 1 in the air. E to the minus 1, which is 1 over e. Around the value of third, so it comes down and then it... So if I just draw that again then, now with that thought in mind, because now we can just say the minimum is here, and then it just seems to go up like so, doesn't it? And here's the minimum, when x is 1 over e. And when x is 1 over e, we get 2 over e with a minus 2 over e. Log of e to the minus 1 is minus 1. So that's the value here. Okay, good. Now let's sketch it. Let's get the plotter out just to check this is okay. 2x ln x from 0 to, say, 5. That's fine. Yes, that's essentially what we've got, isn't it? It comes to minimum here, then it turns and the gradient just continues to increase. And I've used a different scale, presumably here, to the one that's used here, when we did the sketch showing it a lot steeper.